Number 22 says use the finite differences to determine the degree of the polynomial that best describes this data. So what you need to do, finite differences means you're comparing your y values. As long as your x's are evenly spaced, which they are, you'll notice it goes up by 1, up by 1, up by 1, up by 1. As long as your x's are evenly spaced, you just compare the y values. Now for our y values, we go from negative 17 to negative 2, which is a change of plus 15. Make sure you're identifying that it's a positive change or a negative change. To go from negative 2 to 9, it's a change of plus 11. From 9 to 34, it's plus 25. From 34 to 96, that's plus 62. And from 96 to 223, it's plus 127. So if the first row there were constant, it would be linear, but it's not, so we got to keep going. So we're going to now look at the differences of those differences. We call those second differences. So to go from 15 to 11, positive 15 to positive 11, you subtract 4. To go from 11 to positive 11 to positive 25, you're adding 14. 25 to 62, you're adding 37. 62 to 127, you're adding 65. So if those were constant, it would be the second degree or quadratic. But they're not. So we keep going. To go from negative 4 to negative 4 to positive 14, that's plus 18. From 14 to 37, that's plus 23. From 37 to 65, that's plus 28. The third row would be cubic, but since they're not constant, it's not cubic. So we go one more. To go from 18 to 23, it's a change of plus 5. To go from 23 to 28, that's a change of plus 5. Hey, look, they're constant. So fourth row means this is a fourth degree polynomial. So again, whatever row you get to, whatever number row you get to, is the degree of your polynomial.